We'll proceed in flux calculation, divergence calculation, that is position independent and shape independent in calculus. We have come far as flux calculation is concerned. So we have seen that flux calculation is nothing but surface integral. So flux calculation is nothing but surface integral. If I have a surface and there is a velocity field, if there is a velocity and there is a surface, velocity hits the surface, and if you multiply velocity with the surface, then it will give net volume coming out of the surface. If there is a liquid, if there is a liquid and it is going like this and it is hitting the surface, and then how much volume of the liquid that is coming out of the surface. This liquid has a direction. This direction can be like this also. It can be like this also. If it is completely in parallel with the surface, or if this is the surface direction, then if it is completely perpendicular to the surface direction, liquid, then it can be said that liquid is not entering into the surface at all. But if it makes even 89° with the kind of its perpendicular, this is 0° with the surface perpendicular surface vector, even if it makes 89° also, something that will pass through the surface. So if the vector field algebraic vector, that is capital F, and surface vector is a vector, then capital F dot dA vector, D is for integration, capital F vector field dot dA vector integration over full surface is the flux surface integral. If this surface, if this is a surface and I mold it and it becomes a closed surface, if it becomes a closed surface and their velocity is there, if it enters the surface and full surface through which the flux is coming out, in that case, then it is called flux coming out of a closed surface. Closed surface has some peculiar nature. If there is a closed surface, if there is a closed surface, then generally we measure flux density. If surface is a if surface is a closed surface, if surface is a closed surface, then we measure flux density. Flux density means if I have a closed surface, like this is typically, this is a kind of molded surface. Now this is a closed surface. If this is a closed surface and there is a velocity vector field, any vector field, it is coming like this, it is going like this, whatever it is, how much is the flux? How much is the flux that is coming out of the surface? How much is the flux that is coming out of the surface divided by volume of this closed surface? If that is the case, how much is the flux coming out of the surface? And like if liquid is hitting it, then throughout the surface, how much is the liquid that is coming out divided by the volume of the surface? That is called flux density or divergence. So very nicely, we have seen that divergence is nothing but what is tendency inside this volume to generate a vector field. Like if I have a vector field that is coming from outside, it is, consider vector field is going towards x-axis. It is hitting the surface, then it is coming out from here. Since it is toward x-axis and this is x-axis, so where liquid is flowing along the x-axis. Now perpendicular to this surface is along negative of x-axis, perpendicular to this surface is positive of x-axis, and then this is called area vector. This is area vector, positive x-axis. This is area vector, negative x-axis. Now this is the area vector. This area vector is perpendicular to the liquid velocity. So only this side and this side would contribute into the flux calculation. If velocity vector field is constant, like 2i, 3i, 4i, then the velocity vector hits the surface, the net flux of the surface volume that is coming out, it is negative because the surface area vector is along the negative x-axis. If that is the case, then it is negative and this is positive. But both are same. If area is same and same velocity vector is hitting this position and this position, it would nullify each other as far as flux of this surface is concerned, zero. So divergence would be zero. What divergence is? Even though I am saying that velocity is entering from here and velocity is coming out of here, but they are nullifying each other. Inside this volume, there is nothing which is producing the liquid. Liquid is coming from this side and passing from this side. Divergence is surface integral flux divided by the volume where volume tends to 0. Whatever is the case, if there is nothing inside this volume that would produce the liquid, then divergence will be 0. Consider the liquid velocity is not 2i xi. If it is xi, then if this surface is kept at x equal to 2, this surface is kept at x equal to 4, then velocity field hits this surface when x equal to 2. So xi means 2i is the velocity at this location, whereas it hits this surface at 4i, xi 4i. This proves that the net flux of this volume surface is not 0. Here the flux is less, here flux is more, velocity is more. This proves that if liquid is entering here, there is a volume per second coming out from here, more volume per second. If there is a xi is the velocity, then 2 into the surface area. Surface area is considered 4. 8 meter per cube liquid is entering here, and here the velocity is 4. So 4 into 4, 16 meter cube is the liquid coming out here. 8 is entering, 16 is coming out. This proves that there is a motor that is producing liquid that is kept inside this volume. This proves that this volume has divergence. Okay, so if vector field is xi, then this vector field adds to a divergence because surface integral will not be 0. Divided by volume, certainly it will not be 0. Positive divergence means whatever there is a if a surface has positive divergence, means inside the volume there is something that is producing the electric field, producing the field vector, producing the liquid. If it is negative, then there is something inside the volume that is absorbing the liquid. Like sun is producing the electromagnetic field, whereas the kind of black hole, it is absorbing the electromagnetic field. Whereas planets, neither they radiate nor they absorb. If I consider absorption is 0. So sun's divergence is positive and black hole divergence is negative, whereas planet's divergence is 0. Like Mercury, which is actually Mercury, it reflects everything. So that is the story. Now, what is the formula of divergence? Flux surface integral capital F dot dA vector integral over the surface divided by the volume, that is the flux. Divergence, or this is called geometric way. Surface integral divided by the volume is geometric way, whereas algebraic way is if there is a vector field capital F equal to F1i plus F2j plus F3k, then it is dF1 by dx plus dF2 by dy plus dF3 by dz. If you see it, if this is the formula for divergence, divergence is not dependent upon the surface at all, and divergence is not dependent upon the magnitude of vector field. dF1 by dx means how much the F1 component of vector field is changing as we go along x-axis. dF2 by dy, dF3 by dz. If you add, that is the divergence. They can nullify each other. if df2 by dx and df2 by dy, df1 by dx and df2 by dy is positive entity equally df3 by dz is negative entity, then net divergence would be zero, whatever the scenario. Now, if my divergence calculation comes as a numeric value, like we had taken, there is one charge that is kept at the origin and it is producing a vector field, and equation is r vector. R vector means it is omni-spherical. If you go at any distance a, at that moment the vector field is a. If you go b from the origin, it is b. It is increasing. If that is the scenario, then we saw that if I take a cube and cube is centered at the origin, then through geometric way, if I calculated the divergence, that is flux integral, that is flux by volume, it came as 3 only. Then we calculated for the sphere and it came 3 only. This proves that the net divergence calculation is not surface dependent. Net divergence is only dependent upon df1 by dx plus df2 by dy plus df3 by dz, because r vector means xi plus yj plus zk. Then df1 by dx 1, df2 by dy, that is dy by dy is 1, df3 by dz by dz is 1, 3. If vector field is a numeric, if divergence is a number, then not only it is shape independent, it is position independent, because at the end it is numeric, right? So if I calculate now, consider I have a sphere that is centered at 2 0 0 on the x-axis 2 0 0. Now I have a vector field that is xi plus yj plus zk, r vector. Now let's calculate the divergence. Divergence is capital F vector dot dA vector. What is dA vector for the anything in Cartesian coordinate? Minus dz by dx minus dz by dy minus dz by dxi minus dz by dyj plus k dot k dx dy, d area vector, dx dy. This is the divergence, this is the integrating it over the xy plane, this is area vector. Now what is minus dz by dx? What is z? For a sphere, z is x square plus y square plus z square equal to a square. A is the radius of a sphere. Z equal to square root of a square minus x square minus y square. Now minus dz by dx would come as minus 2 minus dz by dx. Z is square root of a square minus x square minus y square. Dz by dx would be minus x divided by square root of a square minus x square minus y square. So minus dz by dx would become xy square root of a square minus x square minus y square I. Similarly, plus y by square root of x square minus y square minus z square. Now the catch is our sphere is centered at 2 0 0, not at the origin. So x would become x minus 2. So it would become x minus 2 divided by square root of a square minus y square minus in bracket x minus 2 whole square. Now it is complicated. Plus y square divided by square root of a square minus y square minus x minus 2 whole square plus 1 plus k I j k, and here we have xi plus yj plus zk dot and dx dy. This is the net flux calculation. If I do dot product, it would become x into x minus 2 divided by square root of a square minus y square minus x minus 2 whole square plus y square divided by square root of a square minus y square minus x minus 2 whole square plus 1 plus z. Z is the square root of a square minus plus z. So z is square root of a square minus y square minus x minus 2 whole square dx dy. Now consider x minus 2 equal to square root of a square minus y square cos theta d theta. This is our explanation. So that is then dx equal to square root of a square minus y square being constant minus sine theta d theta. Here if I settle it down, it becomes x into x minus 2 plus a square minus x minus 2 whole square. Y square gone. So x into x minus 2. If I take x as x minus 2 plus 2, then it becomes x minus 2 whole square plus 2 x minus 2. Now x minus 2 whole square also gone. Now we have 2 x minus 2 plus a square divided by square root of a square minus y square x minus 2 whole square, and on top we have a square root of a square minus y square minus sine theta d theta. Now if I settle it down, it will become square root of, at the denominator, square root of a square minus y square root of 1 minus cos square theta sine theta. Sine theta gone. Square root of a square minus y square gone. Okay, minus remained there. So minus I can keep outside. Now at the numerator I have x minus 2 x minus 2. 2 I can keep outside. So minus 2 is outside. Now it is x minus 2 plus a square and then dx d theta. So x minus 2 x minus 2 x minus 2. So we have said x minus 2 is equal to square root of a square minus y square cos theta. This is what is the initial assumption. So I'll substitute it. Square root of a square minus y square cos theta. Okay, and then plus a square integration with that theta. So if we integrate, then it will be square root of a square minus y square minus sine theta plus a square theta. Now, if this is a sphere, and if I see x-axis, we have taken from this side to this side. That is the x-axis limit. Y is this side to this side. Y is minus a to plus a, where x is 2 minus a to 2 plus a. So whatever it is, if I have taken polar coordinate system, then x is pi, theta is pi to 0, pi to 0 against x against square root of a square minus y square minus sine theta plus a square theta. So 0 or pi sine theta component completely washed out. Now it is a square theta. 0, pi to 0, a square theta pi to 0 will be minus a square pi minus a square pi. And now we have kept 2 outside, 2 outside. Then it would become 2, okay, so minus minus gone, 2 pi a square, 2 pi a square. So 2 is there in the picture. Okay, so whatever it is. Now 2 pi a square. Now integration of dy from minus a to a. 4 pi a square. 4 pi a square divided by the volume of the sphere. Then it will be 4 pi, 4 pi a to the power 3. Okay, expectation was we are calculating this for the upper hemisphere. So it should have come 2 pi a to the power q. So there would be something tweaking we have done, whatever it is. It is 4 pi a to the power 3 divided by volume of the sphere is 4 pi a to the power 3 by 3. So 3. So net divergence is 3 only. You keep the sphere centered at any location, whatever comes to your mind. Whatever comes to your mind, you keep it at any location. Net divergence will be 3 only. So divergence is shape independent always, position independent if the divergence is a numeric. If I take a cube centered at 2, 0, 0, if that is the case where it has unit distance, cube is 1 by 1 by 1, then right side would be 2 and half, left side would be 1 and half. So right side, if I calculate flux into flux, then it will be an equation is xi plus yj plus zk. The right side of the cube, that is in yz plane, the direction is I vector. Left side is direction is minus I vector. So right side it is xi plus yj plus zk. Then dot product will be x. So x dy dz minus 1 to 1 minus half to half minus half to half will be 1 only. X 2 and half is the flux. This side it is minus, it is 1, it is 1 by, it is 3 by 2, 1 and a half. So it will be 1 and a half and minus minus plus, minus minus. Okay, if it is but at it is centered at 2, then this side 1 and a half, this side 2 and a half. So here the flux is 2 and a half positive. This side it is xi dot dy dz minus I. So it is minus x into 1 minus x. X is 1 and a half minus 1 and a half. So 1, 2 and a half minus 1 and a half, it will constitute to 1 only. So in yz plane along x-axis it is 1. Similarly, it is 1 and 1 along other also, and at the end it is 3 only. So for the cube that is centered at 2, 0, 0, the flux is 3, the divergence is 3 through geometric way. And if there is a sphere that is centered at 2, 0, 0, then again divergence is 2, again divergence is 3 only. So this proves that the divergence, if it is numeric, then it is position independent also. Anyway, divergence is the shape independent. Divergence is a story of power of the vector field, not the vector field. Power of the vector field depends upon, divergence at any point. Divergence is calculated at point, not for a shape. Divergence at any point is a property of that point to radiate energy or absorb the energy. So if someone is radiating the energy from that point, if you calculate df1 by dx, there should be df1 by dx. If you calculate df2 by dy, there should be df2 by dy. If you calculate df3 by dz, then there means if something is radiating, then all of a sudden, if you come from this direction, all of a sudden one point is radiating. If that is the case, then if radiation is going on, radiation will decrease in its strength. If radiation is kind of constant, okay, so that is 2i plus 3j plus 4k, certainly there won't be any divergence. Divergence means if there is a radiation, suddenly there will be df1 by dx, df2 by dy, and df3 by dz. So if I am calculating the divergence calculation for this sphere, divergence calculation for this sphere, this volume, then what is tendency of this volume to generate vector field? So if equation is xi plus yj plus zk, then divergence is 3, means anywhere you keep it as per the vector field, all volume has tendency to generate the vector field, that is the divergence. So divergence of sun is very high, that is positive, and divergence of black hole is very high, that is negative. Divergence of earth is nothing as far as the light as far as the kind of light radiation is concerned. So probably we'll have one more session on flux where we'll talk about curve in the flux, and then we will kind of recap it. So that we will see, and then we will move towards parameterization of a surface. what is parameterization, what is parameterization of a surface, and then we will see very famous Jacobian matrix. What we have seen, derivative of a algebraic equation along a vector, that is called directional derivative along a vector. Integration of a vector along a integration of a vector along a line integral, integration of a vector along a surface integral. What about integration of a surface along a surface? Integration of a vector field or surface field along a surface, integration along line, integration along a surface, that we have seen for a vector field. Surface field integration along a surface, volume field integration along a volume. This is what Jacobian talks. Very precious. If someone is concerned about intercoordinate intercoordinate migration, so their Jacobian matrix is very famous. If I have a dxy plane, then it is dx dy. What about in polar coordinate? R d theta dr, but it should be d theta dr, right? If independent component along xy plane is x and y, then it is dx dy. Then xy plane, then independent component in polar coordinate, it is r and theta. It should be dr d theta. Why it is r d theta dr? Then we have explanation that there is an arc and there is a radius which forms the area, that is r d theta and dr. So r d theta dr. But for any kind of coordinate to any kind of coordinate, how we can map? If coordinate is x, y, and we try to map in r theta, then what is dx comma y by d r comma theta? Per unit change in r comma theta brings how many unit of change in x comma y? If it is r, then certainly the dA for the xy plane is r times higher to dr d theta plane. That's why dx dy equal to r into dr d theta. But it is kind of generic, that is Jacobian, that we will see a kind of bigger scope of calculus that is going on. Any area vector integration along any area vector, any volume vector integration along any volume vector, any dimension. This is useful in machine. Whatever we are talking, at the end, we will come in the story of artificial intelligence and machine learning. Their multivariable calculus and vector and then different coordinate system is a kind of ray of hope. So it's a kind of oxygen, or it is kind of the area in which someone should propagate. So those things post flux calculation that we will see.